Probability distributions. All right, so the ideas that we're going to talk about for probability distributions, it's expected value, standard deviation of random variables, transforming and combining, the binomial distribution, and the geometric distribution. So expected value. The expected value of a probability distribution is the sum of the possibilities times the probabilities. That's how I always say it. On the actual formula sheet, I believe it's listed something like this. But it's the possibility times the probability. You do that for all of them and add them up. This number might not make logical sense because it could be like 3.5 people. Do not round it just to force it to make sense. This is also known as the mean of a probability distribution. The standard deviation for a general probability distribution is super complicated. It's like really, really messy and annoying to calculate. So I would just rely on the one variable statistics. You're going to enter the possibilities into one list and the probabilities into another, and that's your frequency list. This is pretty much the only time we're going to use it, but the probabilities would be your frequency list in that case. And then it'll spit out the standard deviation for you that way. Transforming random variables. Remember, measures of center are affected by all of our four main math operations. It's affected by addition, subtraction, multiplication, and division. Measures of variability are only affected by multiplication and division. To combine random variables, we're going to use one of these two formulas. To find the new mean, you just add or subtract the means. To find the new standard deviation, I want to point out this is not a typo. Combining standard deviations is always done through addition. Always, 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 always. Doesn't matter if you're subtracting x and y. It's always done that way. Company sells concrete in batches of 5 cubic yards. The probability distribution of x, the number of cubic yards sold in a single order for concrete from this company, is shown in the table below. The expected value of x is 19.25 and the standard deviation is 5.76. There's a fixed cost to deliver concrete. The profit y in dollars for a particular order can be described by y equals 75x minus 100. What is the standard deviation of y? So this is a transformation, right? It's taking x and doing two things to it. So multiplying by 75 and then subtracting 100. I want to know the new standard deviation. Standard deviation is only affected by multiplication and division, so it's only going to be affected by multiplying by 75. TI Inspire, CAS, sponsor me Texas Instruments. 432. And that's all she wrote. Oh yeah, I'm singing in a dance video. A nonprofit organization plans to hold a raffle to raise funds for its operations. A total of 1,000 raffle tickets will be sold for $1 each. After all the tickets are sold, one ticket will be selected at random and its owner will receive $50. The expected value for the net gain for each ticket is negative 95 cents. What is the meaning of the expected value in this context? So it's basically, it's the average, right? On average, ticket owners are going to lose 95 cents. Oh yeah, that's B. A mathematics competition uses the following scoring procedure to discourage students from guessing. For each correct response, the score is 7. For each question left unanswered, the score is 2. For each incorrect response, the score is 0. If there are 5 choices for each question, what is the minimum number of choices that the student must eliminate before it is advantageous to guess among the rest? So advantageous means if I think about I'm only going to answer it, then I can either get 0 or 7, right? So those are my x's. The probability of my x's, let's say that I've got all 5, right? There's a 4/5 chance that I get no points. There's a 1/5 chance that I get 7 points. I want to figure out what those probabilities have to change to, like based on me eliminating answers, for guessing to be better than leaving it blank. Guessing leaving better than blank would mean the expected value is greater than 2. So the expected value right now is 0 times 4/5 plus 7 times 1/5. So that's really just 7 times 1/5. which is 1.4. So if I have all 5 answer choices, guessing is not advantageous. So A is wrong. So let's say that I eliminate one answer. So now there is a 3/4 chance that I get 0 points and 1/4 chance that I get 7. So again, like before, the expected value would be 0 times 3/4, so it doesn't really matter, plus 7 times 1/4, which is 1.75. Still not advantageous to guess. So let's try again. If I eliminate 2 answers, then it is 2/3 chance and 1/3 chance. The expected value, 0 times 2/3 doesn't matter, so I'm not going to write it, plus 7 times 1/3, which is 7/3, which is 2.333333. So at this point, it is better to guess than to leave it blank, so that's the answer. For a roll of a fair die, each of the outcomes 1, 2, 3, 4, 5, or 6 is equally likely. A red die and a green die are rolled simultaneously, and the differences of the outcomes red minus green is computed. This is repeated for a total of 500 rolls of the pair of dice. Which of the following graphs best represents the most reasonable distribution of the differences? So the way I think about this is, if I'm doing red minus green, it's possible the red one is 6 and the green one is 1, so that's 5. So and it's possible that I actually get, I can't get a roll of 0, right? So this is the biggest possible difference. Conversely, I don't know, maybe it's not conversely. I'm not good at those words. 1 minus 6 is -5. So that's the smallest possible difference. So I just eliminated that, and that, because those don't go from -5 to 5. Oh, hi, Toby. So the only thing I have to figure out at this point is, do I think that it's pretty much uniformly distributed, or do I think it's going to be more unlikely that the ends happen? And I think it's more unlikely that the ends happen because it's going to be hard for me to get -5 or 5. I have to specifically roll a 6 and a 1. Getting a 0 can happen. I can roll 2 1s, I can roll 2 2s, right? There's a lot of different ways I can do that. So I'm leaning towards C. Not leaning towards, the answer is C. A charity fundraiser has a spin the pointer game that uses a spinner like the one illustrated in the figure below. A donation of $2 is required to play the game. For each $2 donation, a player spins the pointer once and receives the amount of money indicated in the sector where the pointer lands on the wheel. The spinner has an equal probability of landing in each of the 10 sectors. Let X represent the net contribution to the charity when one person plays the game once. Complete the table for the probability distribution of X. So, if I pay $2, sometimes I win $0, sometimes I win $1, sometimes I win $10. So, for me to contribute $2 to charity, the net contribution to charity, that means I have to roll a 0, or I spin a 0. So that's spinning $0. Well, that happens 6 out of 10? 1, 2, 3, 4, 5, 6. Yeah. So that's 6 out of 10. For me to donate $1 to charity, I'd have to spin a 0, or spin a 1. That happens 3 times. Probability distributions always have to add to 1, so this must be 1 out of 10. Also, clearly I'd have to roll a 10, and there's only one of them. There's my probability distribution. Easy peasy. What is the expected value of the net contribution? This is that probabilities times possibilities thing. So I'm going to go 2 times 6 over 10 plus 1 times 3 over 10 plus -8 times 1 over 10. So that's 12 over 10 plus 3 over 10 is 15 over 10 minus 8 over 10 is 7 over 10. You're welcome to use a calculator to get 0.70. All right, binomial random variable. So a binomial random variable, we got another acronym, BINS. This is how we verify a situation is binomial. Binary, so it means either success or failure. Independent trials, so one trial doesn't affect the next. The number of trials is fixed, and we have the same probability for every trial. It's not like something weird happens to cause the probabilities to shift once I hit the 5th one or something like that. You do not need to use the formula below to calculate anything by hand. You have to know it because it shows up in multiple choice. What we're going to do in the calculator is binomial PDF. Yes. So P is the probability of success, N is the sample size, or the number of trials, and K is the number of successes that we're trying to observe. That's defined, PDF is to find the probability of exactly 3 successes or something like that. PDF is an exact amount. If you want to find the range of possibilities, so let's say I want to find the probability that I get more than 4 successes. Well, I'm going to use binomial CDF, but remember the TI-84 is really annoying. It only lets you do less than or equal to's. So the way I turn this around, I'm going to do 1 minus the probability. X is less than or equal to 3. So I turn it around and go down by 1. That's how you fix it. Is it? That's not how you fix it. Also, you like how the video just kind of jumped me being stupid? It's going to be X is less than or equal to 4. Since this one doesn't, this one right here, since that doesn't have or equal to, when you do the 1 minus, the or equal to shows up. So let me do another example. If I've got probability of X is greater than or equal to 5, that would be equal to 1 minus the probability that X is less than 5. Now that's not helpful because the calculator still won't do that. It only does less than or equal to's. So what I do to fix that is I go probability that X is less than or equal to 4. So I just decrease by 1 at that point. Great. Great. The mean of the binomial distribution is the number of trials times the probability of success. Standard deviation is given by this formula. Binomial distribution is skewed right when P is low, skewed left when P is high, and roughly symmetric when P equals 0.5. The probability of winning a certain game is 0.5. If at least 70% of the games in a series of n games are won, the player wins a prize. The possible choices for n are n equals 10, n equals 20, and n equals 100. Which value of n should the player choose in order to maximize the probability of winning a prize? That's a bunch of binomials. It's a fixed number of trials. Probability is always the same. You either win or you lose. And the probability is not changing. So let's do n equals 10. For n equals 10, I want to find the probability that I win 7 or more. It needs to be 7 or more because I'm supposed to be winning 70% of them. Well, the calculator doesn't do that probability. It does this, it does less than or equal to, so I got to turn it around. Remember, when we turn it around, we drop the or equal to, but I need it back, so I'm just going to decrease this by 1. Now that's something your calculator can do. Number of trials is 10. Probability of success is 0.5. And number of successes is 6. So I'm going to go into TI Inspire, CIS, and I said that funny, CIS, probability distributions, binomial CDF, and I'm going 10.5. And I get 0.623. N equals 20 and n equals 100 are going to be done very similarly. I'm just going to get the probabilities. Give me one moment. I'm back. So sorry, that's a weird little bounce. I also fixed this probability while I was gone. I had that a little wrong. Clearly, n equals 10 is the highest probability. So I'm going to choose n equals 10. Great. In a carnival game, a person can win a prize by guessing which one of 5 identical boxes contains the prize. After each guess, if the prize has been won, a new prize is randomly placed in one of the 5 boxes. If the prize has not been won, then the prize is again randomly placed in one of the 5 boxes. If a person makes 4 guesses, what is the probability that the person wins a prize exactly 2 times? Okay, so this is binomial again, right? Because they reset the game every time you play. That way it's binary, you either win or lose. They're independent because they keep resetting it. Fixed number of trials, you're going to play 4 times, and the probabilities aren't changing because they're making sure to reset everything. So this is binomial. I want the probability that x is equal to 2. Well, if it's binomial, this is kind of, let's see if I can get back there fast enough. Oh, I can't. Great. This is that formula I was talking about, right? I told you it's going to happen there. It's going to show up where you're forced into this formula. So that formula should be 4, 2, right? So this is n, 4 is n, 2 is k, and then I'm going to go 0.2, because that's the probability of success, squared, 0.8, that's the probability of failure, squared. That's E. All right, last thing, the geometric distribution. The geometric distribution is quite similar to the binomial, but rather than counting successes, it's waiting until success. So to find the probability, we're going to use the formula below. It's very similar to the binomial formula, except we don't have that binomial coefficient. That's what this is called. That tells me the number of different orders in which I could do something. Well, if I'm waiting for the first success, I shouldn't have that. I should fail a bunch of times and then succeed. The expected value, which is the expected number of turns until you succeed, is just 1 over the probability of success. This distribution is always, always, always skewed to the right. An airline claims that there is a 0.10 probability that a coach class ticket holder who flies frequently will be upgraded to first class on any flight. This outcome is independent from flight to flight. Sam is a frequent flyer who always purchases coach class tickets. What is the probability that Sam's first upgrade will occur after the third flight? I want x is greater than or equal to 3, right? So there's a couple ways you can do it. One, the calculator has a geometric CDF built in, and that's probably what I would do. But remember, those CDFs only go with less than or equal to. So I can do that, just rewriting it just like I did before. Now I can go into the geometric CDF. And it wants to know probability of success, which is 0.10. And it wants to know the number of trials, which is 2. When you do that, you pause the video. Okay, 2 things. 1, I got the answer. 2, I fixed a couple things because I misread the question, and I'm sorry for that. But it says occur after the third flight. So that means x would be greater than or equal to 4, right? Not greater than or equal to 3, greater than or equal to 4, because we don't want it to happen for Sam on the third time. Sorry, Sam. So then I turned around the problem. I'm pointing like you can see. I turned this around in the normal way. Just it changed the numbers a little bit. It changed this as well down here. And the answer turns out to be 0.729. All right, part B. What is the probability that Sam will be upgraded exactly 2 times in his next 20 flights? Okay, that's a binomial because I have a fixed number of trials and I'm trying to find 2 successes. So I'm going to find the probability that x equals 2. You're more than welcome to write down binomial PDF. And then we're going to have n equal 20, p equals 0.2, and k equals 2. And when you do that in your calculator, I've already got the number this time, it is 0.2852. Okay, Sam will take 104 flights next year. Would you be surprised if Sam receives more than 20 upgrades to first class? Well, that's just another binomial. Let's find what the probability is, because that's how we determine if we're surprised, right? If the probability is low, we're surprised. So let's do this. Let's probability that x is greater than or equal to 20. My calculator can't do that, so I'm going to turn it around. And if you have an Inspire, your calculator can do that. So you can just enter it and make sure you note lower and upper bound. But if you have an 84, which is most of us, this is where we have to do. So that's 1 minus binomial CDF with n equal 104. P equal to 0.10 and k equal to 19. And when you do that, you get 0.0 0.014. That is a remarkably low probability. Remember, our cutoff for unusualness is 5%. That's less than 1%. It would be very unusual with only a 0.14% chance of happening. And that's probability distributions. Huzzah! Goodbye.